Hello friends, I welcome you in lecture number 25 on vector calculus. In this lecture we are going to discuss about length of a curve. We will see the formula for arc length of a curve in plane as well as in space. So first we recall the formula for length of a curve in a plane. Suppose our curve has parametric representation x equal to say x of t, or suppose some function of t, and y equal to some another function of t, and t lies between some two real numbers a and b. Suppose this is the parametric representation of some curve in plane between these two values t equal to a and t equal to b, and suppose we are interested in the length of a curve between these 2 points, then we have ready-made formula for the length of a curve, and this formula is known as arc length formula. So we have to integrate from t equal to a to t equal to b, and here we will take derivative of x with respect to t, that is x dash t, and square of x dash t, or we can write f dash t also. And here we will consider derivative of y with respect to t, that is derivative of g with respect to t, and square of derivative of g with respect to t, and we integrate with respect to t. So this will give us the length of a curve between these 2 points. Now this is the formula for length of a curve in a plane, but suppose we are interested in the formula for length of a curve C in space, then we will have 3 components x, y and z. Suppose x is given by f of t, y will be g of t, and say z equal to h of t. Suppose these are the parametric equations for a curve in a space, and suppose t lies between a and b, then length of curve in space is given by integral from t equal to a to t equal to b, and here we will consider derivative of f with respect to t whole square plus derivative of g with respect to t whole square plus derivative of h with respect to t whole square, and square root of this sum of squares with respect to t we have to integrate. So here we must have a smooth curve because we are taking derivatives of x, y and z with respect to t. So this formula is valid if our curve is a smooth curve, that is there are no sharp corners in the given curve, and if curve is smooth we can find out derivatives of x, y, z or f, g, h with respect to t. Then we will take square of derivatives of f, g and h, and then we will add these squares. Now we know that if we have a curve in space, then we can represent it in a vector form as r bar t equal to f of t I plus g of t j plus h of t times k, and suppose this is a smooth curve, then we can differentiate this r with respect to t, that is dr bar by dt equal to f dash t I plus g dash t j plus h dash t k, and if we take magnitude or length of this vector, this we can rewrite as r bar dash t also. So if we obtain the length of this vector or magnitude of this vector, so magnitude of r bar dash t will be equal to square root of f dash t whole square plus g dash t whole square plus h dash t whole square. This is the formula for the length of a vector in a space. Square of components xyz components and their addition. Now you can observe that this formula r bar dash t, if we compare these two, then we can replace this quantity. If you observe, this quantity is nothing but length of this vector dr bar by dt or r bar dash t. So instead of writing in this way, we can simply write this as line integral from a to b length of r bar dash t, and we integrate this length of r bar dash t with respect to t. So whenever we have curve in space, we will have its parametric representation, or we will have r bar t equal to f of t I plus g of t j plus h of t k, and t lies between some two real numbers a and b. Then length of the curve in space is given by L equal to integral from a to b. We find out r bar dash t and then its magnitude or length, and whatever we will obtain, that will be a function of t, and we integrate that function with respect to t. So this is the formula for arc length of a curve in space, or we can simply say that length of a curve in a space. So we will remember this arc length formula, and it is easy to remember. First you write down parametric representation for given curve. If it is not given, then you find out derivative of r bar dash with respect to t, then find out length or magnitude of r bar dash t, and then integrate that length of r bar dash t with respect to t from t equal to a to t equal to b. So sometimes they ask you this type of questions in GTU exams. You have to find out the length of a curve in space, and for that we will remember this formula L equal to integral from a to b length of r bar dash t integrated with respect to t. So we discuss one question on the arc length or length of a curve. This question was asked in GTU Winter 2019 exam. Question is, find the length of the portion of the circular helix which is given by r bar t equal to cos ti plus sin tj plus tk from t equal to 0 to t equal to pi. So here we are already given our curve in parametric representation, and this curve is known as circular helix, and we have to find out the length of this circular helix from t equal to 0 to t equal to pi. So as I discussed, first I will differentiate this r bar with respect to t, that is dr bar by dt. So I have to differentiate each component with respect to t. So first I take derivative of cos t with respect to t, which is minus sin t into I, plus derivative of sin t is cos t into j, plus derivative of t with respect to t is 1. So this is our r bar dash t or dr bar by dt. Now we find out magnitude of r bar dash t or length of r bar dash t. So this is equal to square root of square of each component, square of minus t, which is coefficient of I, plus square of cos t, which is coefficient of j, plus square of 1, which is coefficient of k. Therefore r bar dash t is equal to square root of minus of sin t whole square is sin square t plus cos square t plus 1, and sin square t plus cos square t is 1. Therefore we have length of r bar dash t equal to square root of 2. Therefore r bar dash t is equal to square root of 2, and we have to integrate this r bar dash t with respect to t from t equal to 0 to t equal to pi. So now we find out the length of portion of given curve, which is circular helix, and we are asked to find out length for t equal to 0 to t equal to pi is L equal to, formula for arc length is integral from t equal to 0 to t equal to pi length of r bar dash t, which is integrated with respect to t. Here we are already given values of t for limits of integration, and now we integrate this with respect to t from t equal to 0 to t equal to pi, and this we have obtained as square root of 2, and this is equal to square root of 2 integral of 1 with respect to t is t, limits of t are from 0 to pi, and finally we put t equal to pi as upper limit, t equal to 0 as lower limit. Therefore length is pi times root 2. So therefore required length or length of required portion of circular helix is pi times root 2. So this is very simple example. We have to first differentiate given vector r bar dash with respect to t, then we find out length of the vector r bar dash, and then we integrate that length with respect to t from t equal to 0 to pi, and we obtain our answer as pi times root 2. So this question about arc length was asked in GTU Winter 2019 exam for 3 marks. So sometimes they can ask you to find out length of the curve. So remember this formula, and you can easily find out this arc length using this formula. So this is all about this session. I hope you like it. Thanks for